On July 12, 2021, multiple European countries experienced massive flooding, causing deaths and widespread damage. The flash floods started in the UK, causing widespread property damage. Those floods also impacted Austria, Belgium, Croatia, Germany, Luxembourg, the Netherlands, Switzerland, and Italy. At least 229 people died in the floods, and many were injured, and about 300 people are still unaccounted for. Numerous areas were caught and prepared for the floods, which swept away cars, houses, bridges, and everything in their paths. Extreme rainfalls like this one are the most visible signs that the climate is warming because of the increased greenhouse gas emissions, such that a flood like this one has not been seen in about 500 years or even 1,000 years. Studies have revealed that floods are now occurring more often because a warmer atmosphere can hold more moisture, generating more powerful rainfalls and thus worse floods. However, extreme weather events are becoming increasingly common around the globe, whether they are wildfires or more intense hurricanes or floods like this one. Thus, engineers must start rethinking their designs to make them more climate-proof, where they can stand the new loading. Climate change has far-reaching effects on all aspects of our daily life. While warming and rising sea levels are the most talked about effects, extreme weather conditions also influence the way engineers design buildings. Scientists have revealed a consensus that extreme events of the past will not be representative of those of the future, as climate science is not able to precisely forecast the future. This poses a challenge to structural engineers whose design standards are based on the assumption of static climate as observed in the past. Structural engineers don't just consider normal loads like people or furniture into their designs, but they also consider loads like snow, ice, wind, and sometimes rain. These different load conditions affect various aspects of a building's design, from the support structure to materials used in construction. Those loads are purely structural, but changes in temperature can also lead to increased corrosion, decreased strength, and other types of material degradation to existing structures. As climate change worsens, the initial assumptions engineers use to design structures become invalid, and structures cannot handle the new loads that were unaccounted for during the initial design process. Structural engineering is no longer a matter of making sure the building stands under standard loading conditions, but it is also a game of predicting what extremes the structure may face over its proposed lifetime and designing for these extreme loads. There are three possible future impacts of climate change on structures. First, impacts of temperature changes such as drought areas, more frequent freezing-thawing cycles, warming of ocean surfaces resulting in hurricanes and typhoons, thawing of ice reserves resulting in rising of sea level, bigger and abrupt floods, changing of groundwater levels, and heavy abrupt snowfalls. Second, impacts of higher wind speeds such as higher wind impulses, increase in wind intensity, and different wind profiles. Third, impacts of driving rain, which is a combination of heavy rain and large wind speeds, which includes deterioration of structural surfaces, low cycle fatigue of structural elements, and accumulation of damages in structures. A lot of buildings today are designed as green buildings, which is the type of construction that addresses many of concerns related to climate and weather change. Notably though, much of green building practices are aimed at mitigating the effects that the construction industry and buildings themselves have on worsening climate change. This means using things like well-sourced materials, utilizing passive ventilation, and laying out the structure in a way that the environmental conditions can aid in heating and cooling of the internal structure. Also, we must look at concrete if we want to reduce CO2 emissions, as concrete is the most used man-made material in the world. Concrete is made of cementitious materials, water, fine and coarse aggregates. Although the cementitious materials make up the smallest portion of the concrete mix design, it contributes approximately 90% of its carbon footprint when it is ordinary Portland cement. This high contribution is attributed to both the energy used in the manufacturing of Portland cement and the chemical reaction associated with the conversion of limestone to cement. Other cementitious materials such as slag cement and fly ash are commonly used and significantly reduce the carbon footprint of concrete. When engineers are going through calculations for different weather-dependent loading conditions like wind, rain, and snow, they often design based on conditions suited for 50-year or 100-year storms. This does not mean that storms happen once in every 50 or 100 years, but the possibility or probability of these storms happening in each interval. In fact, they can happen more frequently, and indeed they do thanks to climate change. Designing for 50-year or 100-year storm can mean significantly increased costs in building design and construction phase. Engineers are now faced with changing loading conditions due to climate change and are being forced to take more conservative approach in their processes, designing for higher loads than what standards specify, simply because it is very likely that climate change will soon change what those standard designs loads are. When you understand the full scope of a structural engineer's job and how design is dependent upon whether loading condition of a structure, you can understand how climate change will likely transform the current building design process. Engineers can join in research with climate scientists to develop integrated models for extreme events, which combined with observations can give probabilistic guidance for the condition for which structure should be designed, constructed, operated, and maintained. We've only mentioned a few different aspects of how climate change will change structural engineering. However, engineers also must consider frequent fires in their design, which causes them to rethink the choice of materials, shifting to less flammable supplies. As you can see, there are many aspects that structural engineers have to consider when it comes to how their designs will change due to climate change. I hope you enjoyed this video. I learned something from it. See you next time.